Hey everyone, my name is Naveen Morgan, and today I'll be giving you a detailed walkthrough of my Honeypot security project source code. This project is designed to detect unauthorized access attempts and log malicious activities, which makes it useful for cybersecurity research and threat analysis. In this walkthrough, we'll go through how the code is structured, the key functionalities and the components, and how to set up and run the project. So if you want a lightweight honeypot just for logging unauthorized access attempts, we can actually use this script. First, let's take a look at the project directory structure. So the most important file here is the honeypot.py, which contains the logic for detection intrusions. We also have config.json for easy configuration and logs folder where all the attack attempts are recorded. So when you look at the actual source code, so at the beginning of the honeypot.py, we import some key libraries like socket, logging, and JSON. We use socket for network communication, login to track the attacks, and JSON to load configuration settings. So instead of hardcoding the values, we use a configuration file, which is this config JSON, to make the settings more flexible. This actually allows the users to modify settings like the port number or the log file location without changing the actual code. Now let's set up a socket listener, which acts as a decoy service for the attackers. Uh, yeah, where the socket bind, which is 0.0.0.0 for the port, which actually listens to all the interfaces. This means that the honeypot is actually actively listening on a specific port, waiting for incoming connections from the attackers. And then setting up the log attacks, we configure logging to capture all the attack attempts and store them in a log file. Every time someone interacts with our honeypot, we log their IP address, timestamp, and the attempted command that the attackers has used. Now let's look at the main logic that captures the instructions. Uh, the client socket error and the service socket, and then unauthorized access attempts from which uses the attacker's IP address and timestamp. So whenever an attack connects their IP address, it's being recorded, and then they receive a warning message before the connection is closed. So yeah, the second script I provide is more advanced version of the honeypot system that uses Carry, well-known SSH and Telnet honeypot. So I'll walk you through a honeypot malware analysis system implemented using Carry. So this system is designed to detect unauthorized access attempts, capture attackers' interaction, and analyze their logs for security insights. So here we'll cover how the script installs and set up a carry, how it starts the honeypot, and how log analysis works. And finally, why honeypots are crucial for cybersecurity. So this Python script contains three main functions, as you can see. Install honeypot, which installs and sets up a carry, and starting the honeypot, which starts the honeypot service, and then analyze logs, which parses the logs to detect attack patterns. There is also a main menu that lets the users choose an option like this one. And then when the script is executed, the install honeypot function updates the systems with apt update, clones the carry repository from GitHub, and sets up the Python virtual environment for isolated execution. This actually ensures that the carry runs without affecting system dependencies. The start honeypot function activates the virtual environment and then runs the carry script, which is the start.sh, which launches a fake SSH telnet service. This actually logs all the attackers' interactions, such as their login attempts, the command that they executed, and the malware uploads. The attackers will actually believe they're in a real system while we're silently monitoring the activities. The analyze logs function reads carrier's log file, which is the carrier.log, and then filters the attack related messages like failed logins and executed commands. And then it finally print outs the identified attack patterns for analysis. So why this matters? Honeypot Honeypots like this are critical because they can actually detect brute force attacks on SSH and Telnet. They can gather the intelligence on attacker techniques, and they can also provide real-time insights into evolving threats. This setup is ideal for penetration testers, security researchers, and SOC analysts. Uh, so before we wrap up, let's talk about some potential improvements to make this honeypot even better. Uh, we can include real-time alerts and send notifications via email or Slack when an attack occurs. We can use machine learning integrations, which actually uses AI to analyze and classify the attacks. We can also manage to create a dashboard for visualization, which actually builds a web-based dashboard to actually display the logs in real time. And in summary, we built a simple yet powerful honeypot using Cowrie, which installs and configures the Cowrie, launches a fake SSH telnet service, and then captures and analyzes the attack logs. And that's pretty much it. Thanks for watching.